Hey guys, Mr. Gardner here, and today we're going to be talking about inequalities. For the rest of this week, we're going to be working on solving inequalities, graphing inequalities, word problems that lead to inequalities. But today we're just going to work on the solving part of inequalities. So our objective is I can solve an inequality problem by using inverse operations with 80% accuracy. So we want to look at some of the essential questions that we have for inequalities. First off, what is an inequality and how is it different from an equation? How are inequalities used in the real world? For me, I would say inequalities are probably more like real world problems than regular equations are, just because there's multiple solutions. What is the solution set of an inequality? We're going to take a look at that this week. And then how do you graph inequalities to justify your solutions? So you can see all solutions with a graph. So some strategies we're going to go over this week for word problems. Read through the problem, obviously. Identify the important information, numbers and operations. You want to use cubes for this. Identify the quantities. So once we know what quantities are involved in the problem, we'll then put some variables in for those things. We want to be able to write the equation or the inequality so that we can find our answers. And lastly, we want to be able to solve and check. We want to check our answers always. So some keywords we want to keep in mind as we're working through this is at least, which is going to be greater than or equal to. We've got at most, which means less than or equal to. No more than, which is less than or equal to. More than, which obviously is greater than. Fewer than, which is less than. Okay, so these are just different ways of saying these words here, and you're going to see them in word problems. So just understanding what at least means and what at most means. Use common sense for these. It should just make sense that way. When we're solving an inequality, we're going to solve the same way we would solve equations. The only difference being is that these symbols are going to be in place of the equal sign. So we just got to keep in mind, and this tells us that both sides are balanced, whereas these parts are telling us that we don't have that balance. We actually have either more than or less than or an equal amount, but there's always that imbalance involved. So to solve inequality, we want to take the same steps that we use to solve equations. The only difference is going to be that operate or that sign right there in the middle, either equals. It's going to be greater than or less than, or greater than or equal to. So the same idea holds, though, is that when we're solving an equation, we want to isolate the variable. When we're doing a inequality, the same thing is what we want to do. We want to get that variable by itself and the numbers on the other side of the inequality. So let's take a look at an example that we have here. So in this example, we've got some quantity plus 7 is more than or equal to 4. Okay, and so to do this, it's just the same thing we want to do as an equation. We're going to subtract 7 from this side because we want to get rid of it over here, so we just have x. So we know that makes 0, so we're going to get x is greater than or equal to, we're going to keep that same sign, 4 minus 7. Well, we don't have 7 to borrow it, so we'd have to go into the negatives, 3. Okay, or if you remember our strategy, if I've got a negative 7 and a positive 4, then I just take 4 away from 7 and I keep the sign of the bigger number. It's negative. So that's going to give me 3, negative 3. All right. And so that's saying that any value of x that's more than or equal to negative 3 is going to satisfy this equation and make it true. Let's look at another example. This one has subtraction in it. Same process is going to be involved here. We need to get rid of this minus 9, so we're going to add 9 to x minus 9 is greater than 11. So I add 9 to both sides. A positive and a negative make 0. I'm left with x is greater than 20. Okay, so that means any value I put in here that's more than 20 is going to make this statement true. And we can see that. If we put in, let's just say we put in 21 because that's greater than 20. 21 minus 9 is more than 11. 12 is more than 11. That's true. So we know we have a right answer for that problem. Okay, let's look at a third example. This one has a fraction involved in it. Again, a fraction is just division, so we're going to multiply both sides by our divisor there, so times 3. And I'm going to multiply this times 3. And so again, these are going to cancel, which is going to leave me x is less than 15. All right, and again, we could check. So less than 15, so let's put 9 in, because that's less than 15. So 9 divided by 3 is less than 5. 9 divided by 3 is less than 5. Well, that's true. So I know my answer should be good. If you're wondering how this worked out, you got to remember, if I multiply by 3, that's the same as 3 over 1 times x over 3. And if we do that, we can see that these things are going to cancel, because we're going to get 3x over 3. 3 divided by 3 is 1, so that's just going to give us 1x or x. So that's how we got this value right here, in case you were wondering how we multiplied 3 to get rid of that divisor. This is the math here, just so you don't think we're using any wild tricks. It's all sound mathematics. Okay, let's look at one more. This one has 2 steps involved in it. So now again, we're doing the same thing here. We need to get rid of this number here so that we can get this variable by itself. But after we get rid of this 40, we have to do something else over here, because this is multiplication. So we're going to subtract 40 from both sides, because that's the opposite of adding 40. This gives us 0. We just bring that down. So I get 8x is less than or equal to, that's going to give me what? 0, borrow, 0, 1, 12 minus 4 is 8. So 80, but now I have multiplication. So now I just have to do one step. And since that's multiplying, I'm going to divide, because that's the opposite. So I divide both sides by my 8. This becomes 1. 1x equals x. So 1x is equal to x. Okay, so we don't have to write the 1. So we get x is less than or equal to 10. All right, and again, we could check. We could put 10 in. 80 plus 40 is 120. 120 is less than or equal to 120. That checks out as being true. Okay, so we know that this answer does work. All right, you're going to have a worksheet that's going to be attached to this video. In the worksheet, it gives you a little bit of a reminder of the directions. Just pick out 5 of the problems to complete and then turn that in for credit.